Okay, now we're on page 2, number 11. Solve 2x squared plus 16x plus 26 equals 0. Okay, so 2x squared plus 16x plus 26 equals 0. Okay, first thing I notice is I have a greatest common factor of 2, which means I can just divide everything by 2. I can divide everything by 2 because I have two sides of an equal sign, and I can do it on both sides. So when I do that, this is going to simplify down to x squared plus 8x plus, what is that, 13? Is that 13? Yeah. Equals 0. And then I see that this is not factorable because the only factors of 13 are 1 and 13. They don't add up to 8. So that means that I need to do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a is my quadratic formula. So now that I've simplified it down, my a is equal to 1, my b 8, and my c is 13. So when I plug in x equals, I get negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 13 all over 2 times 1. So let's see here, we get negative 8 plus or minus the square root, let's see here. Ooh, 8 squared minus 4 times 1 times 13. I get 12 all over 2. Okay. Now, of course, this can be reduced farther, simplified, because we have this radical that we can simplify. So the square root of 12, if you break down your 12 to, not 2, 3 and 4, and then 2 and 2 here, you got a pair of 2's. So this can come out as 2 square root of 3. I'm going to go ahead and split it up, put each one over 2, because that way we can reduce our fractions also. Because 2 goes into 8 4 times, 2 goes into 2 once. So x equals negative 4 plus or minus the square root of 3. So these would be our two solutions right there. So next question, number 12. A ball is thrown vertically upward from the top of a building, 800 feet tall, with an initial velocity of 80 feet per second. The distance d in feet of the ball from the ground after t seconds is given by that formula. What is the maximum height of the ball? After how many seconds will the ball hit the ground? Okay, so two questions here. First question is, we see maximum height. Anytime we see that maximum height, that's going to tell you need the vertex. So for max height, we are going to use the vertex. So the vertex formula for the x-coordinate is negative b over 2a. And then to find the y-coordinate, we just plug that back in. So in our function, actually it's in terms of d and t. So let me write our distance. So d of t equals, I'm going to rearrange this where it's in the correct order. So I'm going to put negative 16t squared first, plus 80t, plus 800. There we go. And in our case, because it's talking about time, instead of this being x, this is going to be t. So the time is going to be given by this. That's how long it's going to take to reach the maximum height. Then we'll plug in that number to find what that maximum height is. So let's find t here. Negative, our b is 80 over 2 times A, which is negative 16. Make sure that you always do put these in descending order before you start trying to pull out A, B, and C. It has to be in descending order for that to make sense. So negative 80 over negative 32. And let's see. This gives me positive, of course it should be positive, it's time, 2.5 seconds. Okay, now that's not the question it asks for the maximum height here. It says, what is the maximum height? This is just how long it takes to reach the maximum height. So the maximum height, d of 2.5, is going to be negative 16 times 2.5 squared plus 80 times 2.5 plus 800. So let's see what we get here. All right, I get 900. So here we go. So this says that the maximum height is 900 feet. Okay, that's the first question that was asked here. The second question says, after how many seconds will the ball hit the ground? So now, after how many seconds will ball hit the ground? Okay, well, we want to know t when the height is what? Well, if it's on the ground, the height, or d here in our case, is 0. 0 feet. It's on the ground. So what I'm going to do is I'm going to set my equation here equal to 0. Okay, now that it's equal to 0, if I have a common factor here, which I think I do, I think everything is divisible by 16. Yeah, it looks like it is. So if I divide everything by negative 16, that will make everything a lot easier. Actually, here. Divide by negative 16. Of course, make sure you do it on both sides. Here we're going to get positive t squared minus 5t minus 50 equals 0. All right, so this will actually factor, I believe. Let's see here. So 50 would be 10 and 5. Negative 10, positive 5. So when I set these equal to 0, I'm going to get t equals 10, t equals negative 5. Oops. Now, negative 5, of course, for time, it doesn't really make sense, so we'll eliminate that as a choice. And that means that it takes 10 seconds, so 10 seconds for the ball to hit the ground. Okay, so next one, number 13. P of x equals negative x squared plus 90x minus 300 is a profit function where x is the number of items sold, p of x is a profit from the sale. Find the maximum profit and the number of items that must be sold to reach that profit. Okay, so maximum profit, again, vertex. So in this case, vertex to find max profit. This is going to be x equals negative b over 2a. So in our problem, A equals -1, B equals 90. So let's plug them into our formula here. X equals -90 over 2 times -1. So -90 over -2, which I believe is 45. I should know that, but all right. So that means that let's see, what does X represent? X is the number of items sold. So must sell 45 items to maximize profit. And then the maximum profit would be, so the max profit is, let's plug in. So P of 45 equals negative parentheses 45 squared plus 90 times 45 minus 300. Okay, make sure that when you square that 45, you do not put the negative in the parentheses with it, because it's just the 45 that's being squared, not the negative. So plus 90 times 45 minus 300. So I get 1725. Okay. Number 14 says analyze the polynomial. And complete the chart below. State the degree of the polynomial function. Determine the end behavior of the graph of the function. Okay, so what we got here? X minus 4 cubed, x plus 1 squared, x plus 3. Okay, so to find all the zeros, it means we need to set this equal to 0. Now the 7 here, we don't have to worry about it. We can just divide it over. And we can do that with numbers, because that's how you can get rid of them. And then what we want to see is we have x minus 4 equals 0, x plus 1 equals 0, and x plus 3 equals 0. So when I solve them, I get 4, -1, -3. Now, it says we need to put this in this little table here. So let me list out my zeros. So I get x equals 4, x equals -1, x equals -3. The next thing is the multiplicity. So the multiplicity is that exponent there. So it's how many times does this occur as a 0? Well, this right here, degree 3, the x minus 4 is to the 3rd power. That means the multiplicity is 3. For x plus 1 being to the 2nd power, that means for x equals -1, the multiplicity is 2. And for x equals -3, this exponent here is a 1, so it's a multiplicity of 1. All right, and then the question is, does it cross or touch? So I'm going to just put cross or touch. Okay, now we're going to look at the multiplicity and see, is the multiplicity even or odd? Doesn't matter if the 0 is even or odd, that plays no role. Is the multiplicity even or odd? So here, this multiplicity is odd, which means that I'm going to cross at that 0. This has an even multiplicity, so I will touch and turn. And this one is odd, so that means I will cross. Okay. So then it says, state the degree of the, complete the chart, done. State the degree of the polynomial function. So the degree of, of f of x is, now the degree here is what we get when we add up all these exponents. So anything that contained a variable and its power. So here, this is x to the third, x squared, and x. If I add all these up, 3 plus 2 is 5, plus 1 is 6. The degree of this polynomial is degree 6. And it says determine the end behavior of the graph of the function. So the end behavior, what? End? The end behavior. The degree here is even, which means my ends are gonna go in the same direction. And because I had a positive 7 up here, then this is, I have an even positive, which means they're going to go in the same direction, and it happens to be the positive direction. So my arrows are going to look like this. If we want to put that into words, we would say rise left, rise right. Okay. Number 15. When a person gets a single flu shot, the concentration of the drug in milligrams per liter after T hours in the bloodstream is modeled by the following equation. Find the horizontal asymptote of the function f of t and interpret what the horizontal asymptote represents with respect to the concentration of flu medication in the bloodstream as time passes. Okay, so after reading all of that, I'm looking for a horizontal asymptote. So let's, f of t equals 7.6 t over t squared plus 0.2. Okay, so to find the horizontal asymptote, we need to compare the degrees of the numerator and the denominator. So the degree of my numerator, is degree 1. It's this guy here. And the degree of the denominator is 2. Okay, so the degree of my numerator is smaller than the degree of the denominator, which means that my horizontal asymptote is y, well, I'll say f of t, because that's my function. F of t is equal to 0. Okay, so y equals 0 when the numerator degree is smaller. So what does that mean in terms of this problem? So it says, find the horizontal asymptote of the function f of t. Yeah, so I don't know, you could say it this way, or you could say y equals 0. I think I would say y equals 0. We're just going to do that. Okay, what does that mean? It means that, let's see here. When you get a flu shot, concentration in milligrams per liter after T hours in the bloodstream is modeled by this equation. So as the hours go on, eventually you're approaching the concentration of the drug in milligrams per liter being 0, which makes sense. I mean, at a certain point, your body does eventually break down all of any kind of medications that are put into your body, and so it will approach 0. So that's, in words, what that means. That as t approaches infinity, so as time goes on, then the concentration of the drug is approaching 0 in your bloodstream. Okay, number 16. For each rational function below, find the equation or equations of the vertical asymptote and equation of the horizontal asymptote if it exists, and if non-existent, write none. So for part A here, r of x equals 5x over 2x minus 1. So for vertical asymptote, you set your denominator equal to 0 and solve. So add your 1, divide by 2. So x equals 1/2 would be my vertical asymptote. For horizontal asymptote, we compare the degrees, and if the degrees are the same, then we would divide our coefficients. So in this case, degree 1, so y equals 5 over 2 would be my horizontal asymptote. For B, q of x. 7x over x squared minus 1. So my vertical asymptote, or actually asymptotes, set your denominator equal to 0. And if I factor that, then x plus 1 equals 0, x minus 1 equals 0. We get x equals -1 and x equals 1. So I have two vertical asymptotes here for this problem. And then for horizontal asymptotes, I compare the degrees. And just a second ago, we said if the degree of the numerator is smaller than the degree of the denominator, then that means that your asymptote is y equals 0. Okay. Now for part C, whoopsie, we have z of x, that's weird function name, 3x cubed minus 4 over 3x plus 2. The vertical asymptote here, set your denominator equal to 0. And when we solve, we get x equals -2/3. So there's your vertical asymptote. And then for horizontal asymptote, we compare the degrees of the numerator denominator. And the degree of the numerator is bigger than the degree of the denominator. And if that's the case, then we would say there is no horizontal asymptote. So none for this one. Okay, number 17. Find all of the complex zeros for this function. Write the function as a product of linear factors. Just because it says complex zeros, that does not mean that they're all imaginary. It's a common misconception that people think complex means imaginary. Complex includes real numbers. So it could be real, it could be imaginary. Depends. But it's saying that find all of them. Doesn't matter. Real and imaginary, all the zeros. And then we'll write them as we'll write this as a product of linear factors. So 2x to the 5th plus 12x to the 4th plus 18x to the 3rd. First thing I'm going to do is factor out a greatest common factor. My greatest common factor would be 2x to the 3rd. And I'm left with x squared plus 6x. Right? Yeah. Plus 9. Okay, so now, if I can, I will factor this polynomial here, and it looks like it does factor as x plus 3 times x plus 3. In other words, we could say 2x cubed times x plus 3 squared. This is considered a product of linear factors. They are all linear. It doesn't mean you have to write them out more than once. But, I mean, if you wanted to, I would tell you the answer choices would be listed this way, though. So, that's it. We found all... Oh, is this find all of the zeros? Oh, we haven't found the zeros. Okay, so we wrote the product of linear factors. That's done. To find... This is the product of linear factors. The zeros, then when we set this all equal to 0, would give me 2x cubed equals 0, x plus 3 equals 0. So x equals 0 and x equals -3. So there's only two zeros for this one. 0 and -3. Okay. Number 18. And then this is the product of linear factors. Okay. Find all of the complex zeros. Also use the rational zero theorem to list the possible rational zeros. Okay. Let's see here. f of x equals x to the 4th minus 7x cubed plus 14x squared plus 2x minus 20. All right. So In order to begin, we need to, we can't factor anything. No greatest common factor there. So let's list out the possible rational zeros. All right, so to find the possible rational zeros, we're going to list the factors of the constant term. So factors of 20. And we're going to divide those by the factors of the leading coefficient, which in this case is 1. So the factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. All divided by plus or minus 1. So, of course, anything divided by 1 is itself. So these are our possible rational zeros. So 1 and 20, 2 and 10, 4 and 5. Those are all the factors of 20. And now, in order to find some zeros here, we're going to have to start testing them with synthetic division. Now, the easiest way to go about this is to plug this graph into your calculator and then check the graph or the table to see where it actually crosses, instead of just blindly checking. Since, you only have a limited amount of time, we want to make sure that we're being the most efficient with our time. So plus 14. So right now I'm typing this into my y equals, and then I'm going to look at my graph. Okay, and I have to fix my graph here. There we go. Standard. All right. Let's see here. Looks like it may cross at -1 and possibly 2. So on my graph, I see -1 and 2 are probable zeros. So we're going to put -1. I'm just going to make a little list. -1 and 2 over here. I'm going to put -1 in my box. And for my synthetic division, I'm going to go ahead and list my coefficients. 1, -7, 14, 2, -20. Of course, for synthetic division, remember that all of your numbers need to be accounted for. So x to the 4th, x cubed, x squared, x, and then the constant. Draw your line, bring down your first number. 1 times -1 is -1. When I add, I get -8. Times -1 is 8. Plus 14. Let's see here. Is 22. Times -1 is -22. So we get -20 here. Times -1 is 20. And when we add, we get 0. Okay, so turns out there's proof that -1 is a 0. And now, because I know that I saw 2 on the graph here, I can now put 2 in my box and use these remaining numbers here. So we can break this down even further. We're trying to get this down to a quadratic. Right now, this is a cubic because it's 1 degree less than what I started with. So if I bring down my 1 times 2 is 2. -8 plus 2 is -6. When I multiply, -6 times 2 is -12. When I add, I get 22 minus 12 is 10. Times 2 is 20. When I add, I get 0. Okay, so it turns out 2 is also a 0. And what I have left here is x squared minus 6x plus 10. And I am trying to find all of my zeros. That's what it says. Use the rational zero theorem to list the possible rational zeros. We did that. Now we're finding all the zeros. So far I have 2 of them, but those are the only 2 I saw actually. So it looks like the other 2 zeros that I might have may be imaginary. So let's see here. We're going to have to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so -6 becomes +6. This is x equals. plus or minus. It's all over 2. This is 36 minus 40. Right? Yep, 36 minus 40 is negative 4. Okay, well, negative 4, the square root of negative 4 is 2i. So I can, of course, simplify this if I break this down. This is 6 over 2 plus or minus 2i over 2. So 3 plus or minus I. So these are my other two zeros. 3 plus I, 3 minus I. And that's all it asked us to do, find all the zeros. Okay, so here's my zeros. These were my possible zeros up here that I listed first. And remember that when you get a complex, or I'm sorry, a imaginary zero, that you are guaranteed at least 2 because they come as complex conjugate pairs. So if you have 3 plus I, 3 minus I is guaranteed to be 0. Okay, what number was that? Number 18? Okay, number 19. Okay, let's see. 19. Use the rational zeros theorem to list the possible rational zeros of each of the following. So for A, f of x equals 2x cubed plus 12x squared plus 18. Okay, so the rational zero theorems, possible rational zeros. So like I just mentioned, we want to do the factors of the constant, so factors of 18 divided by the factors of our leading coefficient. And our leading coefficient is 2. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. That's my numerator. And then for 2, plus or minus 1, plus or minus 2. What we have to do is take each of the numbers in the numerator divided by each of the numbers in the denominator. So we have plus or minus 1. Let's see. 1 over 1 and then 1 over 2, plus or minus 1/2. Now I gotta take 2 over 1. Now 2 over 2 is equal to 1, so I don't need to write it twice. 3 over 1, 3 over 2, 6 over 1. Now 6 over 2 is equal to 3, so we already have that. 9 over 1, 9 over 2, plus or minus 18 over 1. Now 18 over 2 is equal to 9, which we already have in the list. Oh, I guess I could have just fit this one up here. There we go. All right, so there's all of your possible rational zeros. For part B, then let's see here, g of x equals 5x to the 4th plus 7x cubed plus 3x squared minus 4x minus 19. Okay, so the factors of my constant, so factors of 19 divided by the factors of my leading coefficient, so factors of 5. Now, I know my constant is negative 19 here, but we honestly don't care if it's positive or negative because we put plus or minus with all of them anyways to handle that. So I'm not really concerned about the fact that this is negative 19. So, I mean, I guess I could technically make it, but it doesn't play a role. If it's positive or negative, it doesn't matter. We'll still do the same thing. So we're going to do plus or minus 1, plus or minus 19 over plus or minus 1, plus or minus 5. So to list them all out, I'm going to say plus or minus 1, plus or minus 1/5, plus or minus 19, plus or minus 19/5. And then that's it. So for number 20, says use synthetic division and the remainder theorem. Okay, number 20. All right, complete the following synthetic division to show a function f of x divided by x minus 3. Okay, so the synthetic division is already set up for you. Interesting. 1, negative 2, negative 12, 18, and 47. All right, bring down the 1. 1 times 3 is 3. 3 minus 2 is 1. 1 times 3 is 3. Negative 12 plus 3, so 3 minus 12 is negative 9. Times 3, negative 27, plus 18 is negative 9. Times 3 is negative 27, plus 47 is 20. All right, so what we have here is, this is the remainder here. This is the remainder. And the remainder theorem says that the function value f of 3 is equal to the remainder. So 20. Let's see here. F of 3. Now I'm wondering if they want us to actually give the function here. Let me actually check number 20 on the answer key. Oh, no, that's all I asked for. Okay. Okay. So that's it. And then number 21 here says find f of negative 3 using synthetic division and the remainder theorem if, okay, so find f of negative 3. And the function here is 2x cubed minus 5x squared minus 23x minus 10. All right, so negative 3 is going to go in my box. Cubed, squared, x, and then constant. So we're going to put our coefficients here, 2, negative 5, negative 23, and negative 10. Bring down the first number is 2. We multiply, we get negative 6. This is negative 11. Positive 33. 33 minus 23 is 10. Negative 30. Negative 40. So that means the function value f of negative 3 equals negative 40. All right, well, at this point, I might as well just do one video per page. So that's page 2, and I will do page 3 in the next video.